A very good morning, everyone. Dear 9th standard students, today is 15th of December 2020. This is your Sir Sajid from St. Lawrence High School, Ranibano. Children, in the last class, we have discussed about the potential energy, and I told you potential energy, the definition of potential energy is the energy possessed by the body by virtue of its position, right? If it is virtue of its by nation, virtue of it by its motion, it will become the kinetic energy. When it will be in the virtue of its position, it called the potential energy, and we have discussed that in the previous class with the help of few activities. So when we stretch the rubber band, when we stretch the spring or a slinky, okay, um, it will happens the stored energy. And when we stretch the arrow, right, stretch the arrow, when we release the arrow, so it becomes the kinetic energy. For example, the water stored in the dam, which consists of potential energy, right, and when water is released from the dam, it's converted as a kinetic energy. Got it? So one more activity, let's try to do that. It's very simple chapter. Activity 11.2. In that you can see, children, what is given here is try to understand. First point is take a bamboo stick and make a bow as shown in figure. So bamboo stick and make a bow means so this is called the bow, right? So we can make a bow through the bamboo stick, and place a arrow made of a light stick on it, and one end of the it is supported by the stretched string, right? Next point, with the help of the you can also take the one stretched string for that. Okay, so next now stretch the string and release the arrow. So when you release the arrow, you know that arrow moves, right? Sorry, arrow moves in a which direction? In the straight direction, correct? Arrow moves in the direction, we know that. So when we stretched it, look at here, when we for example, this is the bow, and when we stretched this arrow, so it is the we need to apply sort of energy to it, and it is consist of energy which is called a stored energy, which is not moving energy, which is stagnant energy. This stagnant energy we call it as potential energy, which is in short we write it as PE, potential energy. Kinetic energy we have discussed half mv square, and discussed few problems related few numericals based on that, right? So next point is given. Notice that the arrow flying off the blow. Notice the change in the shape of the bow. You know that the shape. You know when you stretch the string of the bow which lean towards, right, the arrow, the shape becomes changes, right? So when you release the arrow, again the bow which is comes in its original shape, correct? This we know that. Okay, so what happens, let's try to see that. Notice the arrow flying. Notice what is that? Notice the arrow flying of the bow, and notice the change in the shape of the bow. The potential energy stored in the bow due to the change of shape is thus used in the form of kinetic energy by throwing of the arrow. By kinetic energy throwing of the arrow means after releasing the arrow, right, it converts as a kinetic energy. The arrow moves the form of kinetic energy, right? So this is, and next we can see that potential energy of an object at a height. Got it? So before discussing that, I'll tell you one small example, children. You might have observed that uh, if you lift a stone from a ground, it is easy to lift the stone till your knees, okay, and if you want to lift it more the till your head, it is very difficult. For example, I'll tell you, the weightlifters, you might have observed that. For example, weightlifter, I'll show it through the picture. For example, suppose this person, okay, he is lifting the weight, suppose, okay, this person is lifting the weight, and you know that weightlifters had two weights at both the ends, correct? Suppose in order to lift it to his knee height, it's very difficult, and what they have to do in the competition, they have to lift it up to their head high, right? They have to lift in this way, head high. In order to lift it on a head high, they need to apply more force. You might have observed that, isn't it? They need to apply more force. So height is matters. So I don't try to say that height is matters. If you want to lift the object more height apart, because you know that here there will be a gravitation force which is called as 9.8 meter per second gravitation force. When you want to lift the object as a more height, if you want to lift the object at more height, you need to apply more force on it. You know that you need to apply more force on it. Okay, this thing you just remember that, right? So potential energy of an object at a height. So what happens to the height? Let's try to see. What's given in your textbook? An object increases energy when raised through a height. This is because work done on it against the gravity while it is being raised. The energy present in such an object is the gravitational potential energy, because we are raising that object against the gravitation force, right? So gravitation potential energy of an object is a point above the ground is defined at the work done as rising it from the ground to the point of against the gravity. It is easy to arrive at the expression for the gravitational potential energy of an object at a height. Okay, means it's difficult to lift an object at a height. So consider an object. We can say that. Let's try to understand through the picture which is given in your textbook. Okay, we can understand through it. Look at here. This is an object, right? So here, suppose this object we can call it as M, right? Mass M. Consider an object of mass M. Let it be raised through the height h. So it is raised. You know that here it is raised. Let us think that it is raised with the height h. H is for height. Okay. So here you can see that from the ground a force required to do this. The momentum means mass into velocity. You know that force required to raise the object is the equal weight of the object mg. So mg is means what? M into g. M into g is what? M is mass and g is the gravitation force, right? So here the object gains energy equal to the work done on it. Let the work done on the object against gravity W. So W work done is equal to, you know that W is equal to F into S. We have discussed in the previous classes, right? So yeah, W is equal to work done. So when it does mean that when we lift some object, look at here, when we lift some object, the work is done according to the science. So work done formula, we know that. What is the work done formula? So what is the work done formula? Work done formula, we know that W is equal to Fs. F is force and S is distance, isn't it? So here if you take that, so W is equal to force into displacement. So in order to force, instead of force, when we take an example of height, okay, when we take an example of height, so instead of force, instead of F, we write as mg, right? Mg. So mg, m is refers for the mass and g is refers for the gravitation force, children. Okay, g is refers for gravitation force. Here you can see that mg into displacement is, here displacement we don't take s. Okay, we don't take displacement s here, we take h because object is lifted above. So instead of s we take h. So we can write as mg into h, isn't it? Mg into h. So we can write the finally that. So W is equal to, we can write finally as, we can write finally W is equal to, we can write as finally as mgh, right? Mgh. Okay, mgh. M is mass, g is gravitation, h is height. So we can say that the finally, we can say that, children, so finally the formula for the potential energy, which is very simple, PE, potential energy, is equal to mgh, wherein m is mass, g is gravitation, h is height. Okay, so m is mass, g is gravitation, h is height. So this is potential, we can say that potential energy is equal to mgh. Got it? Potential is equal to mgh. M is mass, g is gravitation, h is height. Okay. So suppose if you get a problem that in that they may ask for you the find the potential energy. So you must know the formula, that is Pe is equal to mgh. So if there's nothing in between it, there's a into symbol is there. Okay, remember that. So m is mass, g is gravitation, h is height. Let's try to see that. Okay. It is useful to note that the work done by gravity depends upon the different vertical heights of the initial and final positions of the object, and not on the path along with the object is moved. Figure 11.8 shows the in case where the block is raised from the position A to B by taking two different paths. Let the height A be h. In both the situation, the work done on the object is mgh. Okay, suppose you just see that here. Here it is straightly, it is object is taken up, okay, raised up. Here it is lightly in the path. In the second picture, the path of the uh, raised height, raised object is little different, but in the both the cases the work done will be same, isn't it? Because object has, because you can see that object has rise to same height. Okay, but path is different, but irrespective of the path the object height will be same. So work done, we can say that in that case both are same, right? That's a simple point. So next we can see one small problem which is very simple. Look at here. Find the energy possessed by an object of mass 10 kg. So m is given 10. Okay. So when it is at the height is also given 6. Okay, gravitation 9.8, we know that. So formula we know. What is that? Mass of an object. First we write the given things. So mass of an object 10 kg is given already. Displacement nothing but in case of a potential energy, it's a height. Okay, so height is 6 meters is given. So acceleration due to gravity nothing but small g, which is given 9.8. So potential energy formula we know that. How much? What is the formula? So what is the formula? You can see that formula. Okay, potential energy formula, what is that? mgh. Just now I told you, mass, gravitation 9. Just we substitute the values. Okay, mass is given 10 and gravitation is 9.8. Okay, and then it is 6. What is the height is given 6. Okay, so total answer comes as 588. Okay, so here we can able to simplify very simply, that is 9.8 decimal point is there. You just remove the decimal point and directly you can multiply. After that one from the unit place you can put the one decimal point, so that you can get the answer. So answer comes as 5880. So point 0 if there, we don't consider the 0, so we write the directly answer as 588. So what is nothing but the unit is also joule. You can see that the unit is joule, so answer becomes 588 joules. I hope you understand this. Okay, so next we can see, look at the next problem which is also very simple. An object of mass 12 kg is at a certain height